Okay, so let's move on for the challenge problem of the chapter 13, Intro to Algebra. So, yes, the first question. The first question is x minus y and x squared minus y equals this. So this is pretty typical, is we convert into a quadratic equation. Okay, so from the first one we know x equal to 3 plus y. So when we substitute this one to the second equation, then it become a quadratic equation of the y, right? So this will be equivalent to be the y squared plus the 5y plus the 10 equals 0, right? So we want to test the delta is equal to 5 squared minus 40 is less than 0, so there is no real roots. Okay, so the only thing I want to introduce here is, let's see, a general quadratic form ax squared plus the bx plus c equals 0, right? We can do the divide by a, because a is not 0. A is 0, it's not a quadratic form anymore, right? So we can say we can rewrite it, e plus c over a equals 0, right? So we can put a perfect square here. 2a of the square, right, is equal to the, we add this one on both sides, then minus the c over a, right? So now you can see on the right side is the 4a squared b squared minus 4ac is equal to x plus b over 2a squared, right? So here is the perfect square, right? So this one need to be greater or equal than 0. You have the real roots. Okay, so that's why we define this one as a delta, right? So now we become the x plus b over 2a is equal to plus minus root of the delta. If delta greater than 0, then we have the I'm sorry, this is 2a over delta. Okay, this is delta, I'm sorry, this part is equal to delta. Okay, so that's why the x equal to the 2a minus b plus minus root of the delta. Okay, so that's why the delta is b squared minus 4ac. Okay, here's the definition. Okay, next. So we try to solve this equation. Now we can see the y equals the z squared, then y squared minus the 4y plus 3 equals 0. So we have the y equals 3 and the y equals 1. From y equals 3, we know that z equals plus minus root 3. From y equals 1, we know z equals equal to plus minus 1. This one. So what is the largest value of the k? That this one has the 1 real root. So this one is the delta is equal to the negative 5 squared minus 4k greater equal than 0. So we know the k less than 25 over 4. So that's why the maximum is 25 over 4. This one is, so many people calculating the fractional like this way. We want to see whether this is possible for a, b belong to the real. Okay, now let's solve it. Is a times b, a plus b, then equal to the 2 of the a plus b is equivalently to the a squared plus the b squared equals 0, right? So here is the only solution, is a equals 0, b equals 0. But the problem is you cannot, the denominator cannot be 0, right? So there is no real solutions. So find this one. So for the first problem, so we can see a, we know the p plus q, the two roots, okay, is equal to the 5 over 3 then p times q is 8 over 3. Then we know the p square plus q square is p plus q of the square minus 2pq is 5 over 3 of the square minus 2 times 8 over 3. Then this is the 25 over 9 minus the 9 over 48 is negative 23 over 9. Okay, so the b, let's calculate the b is the p plus q is 2 of h, and the p times q is negative 3. So the p square plus q square equals 10 is equal to the 2h of the square minus the 2 times this plus 6, so equal to the 4h square plus 6. Right, so solve equation, you can see h equals plus minus 1. So suppose we have quadratic equation are rational, coefficients are rational. How we use discriminants? Let's see, it's the ax squared plus the bx plus c equals 0, right? Based on what we definition is delta equals b squared minus 4ac. Then we have the greater than 0 equals 0 less than 0. So it's two different real roots, right? It's two equal roots and complex roots. Okay. Next, so it's still the same thing. We need to use the first one to give us the x equal the 4 minus 3y. Then substitute into the second one, so we have the 4 minus 3y of the square plus the y square minus 4y minus 12 equals to 0. Then it's the 10y square minus the 24 and 28y, then plus the 4 equals 0. Equivalently is 5y square minus 14y plus the 2 equals 0. So we can have the delta is 196 minus the 4 times 5 times 2 is the 40 is 156. So this one is equal to what? Is equal to 4 times 39. Okay, so that's why the solution of the y is equal to the 10 over the 14. The plus minus the 239 is equal to the 5 is 7 plus minus 39. Then we solve the x is equal to for the 4 minus 3y is 4 is minus the 3y, right? 3y. So the answer will be 5 of the negative 1 minus plus 39. Okay, next. So we want to find all the not real, right? So the first a, you can see if the x squared is equal to the 144, right? So you can see if we represent the x is aej of the theta, right? So square is a squared, then ej 2 theta is equal to the 144, right? So here you can see the theta can be the 0 degrees and the 180 degrees, right? Because 2 theta, you need the 2 theta equals 2k pi, multiple of the 360 degrees. So that's why x equals plus minus 12. Okay, so the second one, I will very simple again, right? Is equal to 81. Then we have the x equals to the 3, then ej 2 pi over 4 times the k. Then k equals 0, 1, 2, 3. Okay. Next one is the same thing, c equals, so x equals 27, so we have the x equals to the 2 pi over 3 times k, then k is 0, 1, and 2. The d is the z of the 3 equal to the negative 8. Right, so you can see the z is equal to the 2, the ej of the 2 pi pi over 3, then ej of the 2 pi over 3k, then k equals 0, 1, and 2. And the e is the x6 equals to 1, so x equal to ej 2 pi over 6 times k, then k is 0, 1, up to 5. Okay, so for this one, let's see. Okay, so we can have a quadratic equation of the z square minus z, then minus the 5 minus 5i equals to 0. Then we can solve the roots and take the real parts, right? So the delta is 1 plus the 4, 5 minus 5i, so it equal to the 21 minus the 20i, so it's equal to the root of the 21 square plus 20 square, the theta, so that's is 29 cosine theta plus I is 29 sine theta. Okay, so now we can see that 29 cosine theta is equal to 21. Then we have the z12 is the roots is equal to 2, 1 plus minus the square root of the delta, so it is the 2 is 1 plus minus the root of 29, right, and half of the theta. So the real part of the real part is equal to the half is 1 plus root 29 cosine theta over 2, and the real part of the second root is 2, 1 minus 29, then cosine theta over 2. So now we can solve the z1r times z2r is equal to 1/4, then minus 1 minus 29 times cosine square of the theta over 2. Now we have this, right? So now per trick we know the 29. Then cosine theta is 2 cosine theta half square minus 1 is equal to 21. Then we can solve it as the 2 cosine theta over 2 is equal to 21 over 29 plus 1 is equal to the 50 over 29. So now we can solve the cosine square of the theta over 2 will be the 25 over 29. Okay, so now we can plug this in back, right? So now we know the z1r times z2r is equal to the 1/4 of the 1 minus the 25, so it's negative 6. Next, so we want to solve this golden ratio, right? So now let's make an equation. Okay, let's make a cross product. So it's the WL plus the W square is equal to L square, right? And let's divide by W square on both sides. Okay, so L over W plus 1 is equal to the L over W square. So the L over W is what we want, right? So L over W equals T. Then we have a quadratic equation is t square minus t minus 1 equals 0. So delta is negative 1 square plus 4 is 5. Then the t is equal to the 1 plus minus root 5. because the L and W are width, right? They greater than 0, so of course you cannot take the negative. That's why the T, only T works is this. Next. So we have this one, and we have the PQ are the roots of this. We want to find the quadratic of that, right? So we have the P plus Q is equal to the -2, and P times Q is equal to 2. Now we want to find the Y, right? So the 1 over P plus the 1 over Q is equal to the PQ, then P plus Q, then equal to the -2 over 2. So it's -1, okay? Then the 1 over P times the 1 over Q is 1 over PQ is 1 over 2. So now the roots, the Y is Y squared, the plus the Y, then the plus the 1/2 is the quadratic form with the roots of the P and the 1 over Q. So this one, okay, so the first one we know the x squared cannot be equal to 2, right? And then we can quadratic form, there is the x squared of the 3 minus 2 to the 3, right, is equal to the x squared minus 2, the x cubed, the x fourth, then plus the 2x squared, and plus the 4, right? So this one is that. So this one has been reduced to the x fourth plus the 2x squared, then plus 4 minus 12 equals to 0. So now we have the x fourth plus 2x squared minus 8 equals to 0. So this is 2, 4, right? So 1, 1, and we have 4, -2. And so that's why we can derive as x squared plus 4 and x squared minus 2 equals to 0, because we know this part cannot be 0, right? So the only solution from here is the x squared equals to -4. That's why x equal to plus minus 2i. Okay, this one. So we want to prove this one is the solution, right? So from here we know the solution is x equals 2a -b plus minus the delta, right? Here is the delta. Think about it. Okay, this is the 2c 2a. Okay, so let's flip it. Okay, so means 1 over x, okay, is this. So this is must be a solution to another quadratic form, right? Now let's see how we can do equivalently, okay? So you can see here is c, so we want the c have to be a quadratic form, right? Now let's see how we can do it. Plus the bx plus c equals 0, right? So it's equivalent to quadratic form of the divided by x squared is the a plus b over 1 to the x plus c over 1 x squared equal to 0. Okay, now this is the quadratic form of the y. Let's see, okay? The cy squared equals to 0. So the results, the solution to this one is the 2c, right? You can see we have the 2c now, -b plus minus is the delta, it's the same thing, it's the y, right? So y equal x over 1, so you can see now we can get it, right? So this is the 1 over x, this is the quadratic solution, this is the solution to this quadratic form, right? Then if we solve to the x, then we know the x also equal to the -b plus minus delta, that's the denominator, and numerator is 2c. This one. So let's see. So we have the the rs, right? We know the x squared plus the bx plus c equals to 0. We know the r plus s equal to negative b, and r times s is equal to c. Then the second one, we have the x squared plus the ex plus f equals 0. We know the r plus 3s is equal to negative e, and r times 3s is equal to the negative f. So we want to solve the last one, right? We want to see the x 2x squared plus the b plus e over 2x plus the c plus f over 2, right, equals 0. So let's take out this 2. Then we know the x squared plus the b plus e, right? B plus e over 2 means these are negative of the r plus 2s of the x. Okay, then we plus this one, right? As this one plus together is 4rs, right? Divided by 2 is 2rs, okay, equals 0. So you can see 1 minus r minus 2s, it works, right? So it becomes x minus r, then x minus 2s equals to 0, means the solution is one is r, and the second one is 2s. Okay, so this is the answer. So we are trying to solve the value. Okay, let's see, because here is the 6, right? We have to expand, but when we expand, we see this common term. So let's see, at r squared plus 3r equals y, then we have the y squared plus the 5y minus 6 equals 0, right? So now we know 1 and the 6 negative 1. So we know the y plus 6 and y minus 1 is equal to 0. So we know the y is equal to negative 6 or y equals to 1. So for y is equal to negative 6, right, we have the r squared plus 3r plus 6 equals to 0. For this one is y squared plus 3r minus 1 equals to 0. Okay, so now we can solve this equation. The first delta is 9 minus the is negative 15. For this one is 9 plus 4 is 13. So here the R12 for this equation is 2a negative b plus minus 15i. Okay, for this one is R12 is 2 negative 3 plus minus root 13. Okay, the last one. So we have a integer. So we have the a belong to the positive integer, and also b also belong to integer. Then we know the b greater equals than 0 and 2, 0, 0, 2. Now we want to see this equation and this equation both have integer roots, right? Now let's solve it. So x squared plus ax plus b equals to 0, right? If it has integer roots, means the delta is equal to a squared minus 4b, right? So it's a k squared. Now the other one is the ax squared plus the ax plus the b plus 1 is also the delta is the a squared minus the 4 of the b plus 1 is also a k, right? So this number is smaller, right? Let's see, it's k minus delta of the square. So delta is integer. Okay. So now we have these two, right? Both of them are integers. Now let's see what we can do it. Okay. So now we have we can use this is the 2 and this is the 1. And if we use the 2 minus 1, right, what we can have is on the left side is negative 4 is equal to the delta minus the 2k of the delta, right? So now we have the we have a quadratic term for the delta, right? We try to solve this delta. So it's minus 2k of the delta plus the 4 equals to 0. Now let's try to solve it, okay? So we also have it's the 4k square minus the 16, right? So the delta will be equal to the 2a is 2k plus minus of the 2 of the k square minus 4, okay? So equal to k plus minus of the k square minus 4, because this must be integer, right? Yeah, because k is an integer, right? It's this integer. K is an integer, and we also need this one to be integer. That's why delta is an integer. If delta is an integer, now we know here is integer. We know this one must be integer. So we want to the k square minus 4 equal to a m square, right? So now we can see it's k minus m, and the k plus m is equal to 4, right? Since then we know the k minus m is less than k plus m, then we can try to solve it. So let's see, k minus m and k plus m, then it's the less or equal, right? So we can solve the k and we can solve the m. So they are they are all even or odd, right? Yeah. So that's why if we factorize a 1 4, it doesn't work, right? So now it 2 2, that's the only thing that can work. If there's a 2 2, that means k equal 2m equals 0. Okay, if k equal 2m equals 0, the only delta is equal to 2, right? If delta is equal to 2, that means this one is k square, means the a square minus 4b is k square, right? And the a square minus 4b minus 4 is equal to k minus 2 square. Okay, so now we can do the and what do we solve? We solve the k equals to 2, right? So k equals to 2 means the k equals to 2, that means the a square is equal to the 4 of the b plus 1, right? Okay, so 4 of the b plus 1, and then we know the range of the b, right? So b plus 1 greater equal than 0 and less or equal than 2203. Okay, so now the a square must be a multiple of the square. Must be a square number, right? On the right side it must be a square, so 4 is a square number, so b plus 1 must be a square number. And the b plus 1 is greater or equal than 1, then less or equal than this. So that's why the b plus 1, right, can be the 1 square, 2 square, up to the 44 square. Okay, then how many of the a is possible? So that's why there are 44 possible solutions. Okay, so that's it for for this chapter. Thank you.